welcome to the Intelligent Document Finder demo. So the outline is, let us introduce what is a digital solution company and then requirements. What requirements this tool is supposed to cover. Then the approach. So what is the best approach we are following, then algorithms involved, then installation manual for both Windows and Linux, and then the semantic search, what and all steps involved, and then the test report. So what and all test cases we executed, then pending report, work whatever still need to be done, then the demo, whatever demo what we see now. The company is Digitron Solutions, and then the website is http://digitonsolution.com. So the digital transformation technologies like artificial intelligence, blockchain, and IoT cloud-based solutions are provided. So currently the leadership it consists of founder and the CEO of this company, myself, Dr. Anbunathan R. The requirements are like intelligent document finding. So it's a tool which enables semantic search for the user queries and then find the document in the system. So it gives a rank which document is more relevant, and then it supports different document types like PDF, Word, XLS, PPT, and also it provides a facility like a human tagging, like manual tagging as well as automatic tagging. The approach is we have to make one MERN-based web application and then desktop client. The desktop client consists of a Flask web server, machine learning models, documents parser, SQL DB like PostgreSQL SQL is used, and then it takes the input documents, and then the MERN web application mainly it performs the user authentication, and then UI provides UI also. It has the MongoDB connectivity, and then it stores all the user information in the MongoDB. So basically the web application is deployed in AWS EC2, the model is prepared, and then using again AWS EC2 P3 configuration, and then the model files are kept under the project directory. Then the Python Flask application, the web server is used in the desktop client, and then the web application is started in the Chrome. Let us have a quick look on this MERN application as well as the desktop client. The desktop client is basically a Python based application. So we can see different Python files like main.py, then this is the Postgres handler, and then this is the TK parser, and this is semantic search. It has different APIs for semantic search. So in this project directory we can see a data folder is added. In this data folder different subdirectories are there. One is process data, where the input files are processed and then kept, and then we can see here sequence to sequence model is available here in this folder, and then language model is available in this folder, and then the embeddings models are available in this. Finally the output is generated as a NumPy file, so for each document involved. So we can see here the Python files as well as the data folders are arranged for the desktop client. Now time being this it's running now. This Flask based, here you can see the Flask is used, Flask web server is used. So the Flask based web server is currently running. So Same way, let us see how the uh, man based application is, how it is looks like. So let me log out and then log in again. You can see the login screen here, and then I am entering email ID and password. Then it enters into the dashboard. So we can see different tabs are there. So the first one is the list of directories what are all already added. So if I want to add new directory, I can add in this screen. Then if I want to search some query, I can search here. Then the result, whatever search query I am entering, I am getting the result here. And then finally the documents, whatever paragraphs we have, all these are ordered in this. We can see everything in this screen. So this is the learn-based application which is running on AWS EC2, and this can be opened with the IP address 54.225.26.77. Then so let us continue the slide. So here we can see the different functionalities of both man application as well as the desktop client. So mainly the Flash web server communicates with the man-based web application through internet, and then the machine learning model, whatever we saw available in this, it is making the predictions, as well as the document parser takes input document, then parsing, storing the paragraphs in the SQL. So the man application provides the UI and then gives the user authentication, and the user details are stored in the MongoDB. So we will move to the next slide. So what are all different algorithms used in this particular application? Step one is process data. So whatever documents we are taking the documents, and then we are parsing, and then we are extracting the paragraphs. Then the step two is we are making summary of paragraphs using sequence to sequence model. Then we are training a language model to encode the natural language phrases. Then we are training the model to map the vectors to the embedding space, and then finally a semantic search tool is created. So the installation involves different steps in different part of the application. One is the desktop client, the desktop client involves different installations like install Python 3, Flask, also the installation of requirements, different requirements of different packages, and then it involves the installation of PostgreSQL, Java 8 need to be installed, and then we are extracting the source code present in this particular zip file, and then the Google Drive gives the data, whatever data involved, the different models and all we can download from there and add it in the project path, as we saw in the Python data, the Python project. So we can see here different folders are involved here. Like this one is having the code embeddings model. Then this is the language model prepared with the FastA and Torch. And then this is particularly sequence to sequence models. The finally output will be displayed as the NPOI file. So let us see how the model preparation, what are all steps involved in the model preparation. So here AWS EC2, again P3 configuration required, GPU is required, TensorFlow, Keras, FastA, Torch and all required. Then again we have to extract the files, whatever source code, and then step one here is the pre-processing the data, like WikiHow data is used here. Then we are training the sequence to sequence summarizer model. Then language model is prepared, and then the embeddings model is prepared, trained and prepared. So let us see how what are the steps involved in the web application preparation. Here MERN-based MERN is involving React.js, Node.js, Express.js and MongoDB. Then we have different features like sign up, login and forgot password. Then mail drop IO is used for handling the mails during the development stage, and then we finally have the MAN application running in the AWS EC2 where Voodoo virtual machine is Nginx server is used, and then the IP address 54.225.26.77 is used to deploy this particular application. Let us move to the next slide. So let us start how semantic search is working. So here we are starting the semantic desktop client as we saw in the Python. The Python project, we can see already the desktop client is started, and different files also we saw already. So the next slide, we are seeing the first page of semantic web page. We have to click on the search document link. Then it is basically running on 54.225.26.77. So the next slide, we can see the sign up page. Basically the sign up or login page where user can enter email ID, then username and password to sign up. Once signed up, the email ID and password can be used for the login page. Then once the login is done, it enters into the dashboard. The dashboard consists of different tabs like the directory, then create directory, then search document, search result, and then document reports. So we can see here how the create directory SQL is looks like. Then here we can enter the directory path, and we can select the directory, the option, and then once this is selected, it will start parsing the documents. Then once the documents are parsed, the paragraphs are stored in the SQL DB. Then automatically this option is SQL file option is selected once the files are successfully added to the database. So in this screen, we can see the list of directories are appearing here, and then automatically the SQL file option is selected here. Suppose if you add new documents in a particular directory, then user has to change the edit, press, and then you change to directory. I will show that one. For example, if this directory is some files are added, then you go to edit, then change to directory, then update this. You can see here it is appearing as that directory. So I will change back to SQL. So now it is changing back to the SQL. Then the delete feature also we can use if we require. Then let me add a new directory and show how the directory is working. See, for example, in this document, suppose I want to add some file, so I can add some file, and then I can check whether for example, I want to add some particular file. Let me add the installation package or some file like that. I'll take this file, then I will go to the new one. I'll add here. Then I will add, let me take this link and then copy this link, and then I will go here and add in this directory path, and then I will select, I will add the directory file. Now it is added here. Now you can see the first time it is added as a directory. Now when I press the this the set search environment, it will start here. You can see here it is starting already. In Python project we can see now the desktop client already, the whatever new directory I added, it is successfully passed, and then the search environment is set. Now we can see in the main application. In main application we can see the environment is set successfully. We say OK, then it will go to the search window where I can enter the query now. So I am going to enter one new query. New query can be this is some query. Then I am clicking on the search button. So once search button is clicked, see the search result. So it is going to the search result. It is showing what and all documents very near to the appropriate to this search query. So it is ranking from 1 to 10 based on the distances, cosine distances 0.742. This is 0.744. So here the distance are increasing ascending order. The rank is also 1 to 10 ascending order. So the lowest distance is number 1 rank. So that is the way it is functioning. Then once it is done, my search results are displayed. Suppose I want to display the all search result based on the chronological order. The previous search also, whatever we searched earlier, that also will appear. You can see here the previous chronologically search results also appearing. So then that is the way the search query is working. So here we can see here on clicking search around the input documents of 1004 paragraphs are added. Then the SQL file. Now if we go and see once it is successfully parsed, then here you can see this type is changed to SQL file. So then in some new documents, if some new documents are added, then the user has to select the directory manually. So the search query, again, as I explained, we have to enter the search query and we have to search button, we have to press, then it will start searching. So then once the search is done, the search result is displayed in this window. The search result is displayed in ascending order. The cosine distance are used to determine the rank. I display all search results to display all previous in chronological order. So in chronological order we can see all the search results. Let us move to the next slide. So what is the next feature? Next feature is it displays all the document records, all the paragraphs it displays. That also we'll see. So we'll go there to the main application, then open this document records. You can see all the paragraphs are displayed here. Suppose I want to refresh, we'll go and press on this button, then it will get the refresh screen. Here 1131 paragraphs are there. Then one more feature here is adding here manual tag for this particular paragraph. I want to add Here already added one manual tag. Now I'm going to add for second paragraph. So edit this, go there, manual tag for second. So manual tag is added. So once I click, it will not appear here, but when we press this button, display document record, then it is here. So you can see now how many records are there, 1131 records are there. So like this we can add the manual tag also. So the steps are, all paragraphs are displayed under document cards. Manual tag can be added using the edit button. So that we did now. Then enter the string and press update manual tag. Update manual tag. So once we update the manual tag, then it will then you would refresh this screen. Then it will appear in the under the manual tag column. So now we'll see how what are all test reports what test cases we used. So one is multiple folders, like we done multiple folders here. For example, here different folders we taken care, and on that add different folders. So different files are there. So if we see here what are all the files are here. So if you go and see, the first folder has one file, second folder has one file, third folder has around 11 files. See, 9 and 9 files. So 9 plus 2, 11. Then last one what we added now is 12 to 1. So almost 12 files we entered, and then we check, and then multiple wires also we check. So let us see now how multiple wires. We saw the demo in Windows. Now we will see the demo in Linux also. For that we need to prepare a Linux machine. So in this case, the Azure, Microsoft Azure is used to prepare a virtual machine, Ubuntu based virtual machine. So we are running the Ubuntu based virtual machine. Then when you go to the Ubuntu based virtual machine, you can see here similar way the Python scripts are running in the command line, and then Maven application is running in the in Firefox. So here also we can see the list is displayed here, and then we can create new directory also. In this case, already 3 documents, 3 directories are added, and then when we press the search environment, so here you can see it is the setting the search environment. So the search indexes are created, search environment is set. So a pop-up appears, environment is set successfully. Press OK. Then it will go to the query window where we can enter the query. So this is I can enter some string here. This is 10th query. I will search button when I press. It is searching. You can see here the backend, the desktop client is running parallelly, and then here it is search results are appearing. So here rank, rank it is displaying. Same way like how Windows are working in the way, same way it is working in the Linux environment also. So we can press the display all search results. Then we can come here, we can come and see how chronologically it is displaying all the search results. You can see here. So same way now we can see here. So in the document records, you can see here how many paragraphs are appearing. See here 1110 paragraphs are appearing. So you go back and refresh also. You can refresh here manual tag if I want to add. So new manual tag, so manual tag, dead manual tag. So then not appear here, but when you refresh it will appear. So the same way how we are working in the Windows, same way we are working in Linux also. So you go back to the so this is the way the multiple OS also supported. So the multiple users also one of the test case. So here in Windows the one user and then in Linux another user, both are using at the same time, it is supported. So then we saw already directory and SQL how is handled. So whenever the directory is added first time, it parses all the files. When all the files are parsed, then it will automatically select as SQL. So next time when we run the search query, it will not parse the document, it is one time parsing. That way it is more efficient and time saving option. So the evaluation criteria for this particular application is, one is multiple document support is there or not. Yes, it is supported. PDF, PPT, PPTX, docx, then text, XLS, CSV are supported. SQL database, Postgres, SQL is supported. Storage directory supported. Automatic tagging, manual tagging, semantic search, everything supported. Then abstract is summarization. Only paragraph wise is added now. Document wise is still not ready. Then the independent publication also there, yes, it is man based. And then performance, first time parsing document takes some little time, so the next time onwards it will not parse the document, saves a lot of time. Then the accuracy of the fast type based language model is 96%. There is no extra features, marks also I think available. So what is the pending work now? There are a lot of scope to improvement. So document wise summary need to be supported. Currently only paragraph wise summary is considered. Then automatic installation of desktop client. Now manually we have to install the desktop client. Then I go to automate this. And auto sense any change in the input document. Then suppose input document one is added, one is deleted, then the application should know that. Then currently model is built with sample data. Only 1000 paragraphs are considered as in the WikiHow, but WikiHow has 2 lakh. We need to consider the more paragraphs are better accurate results. Then offline, working offline is possible or not, that we have to explore. Then auto sensing of deleting. Suppose one folder is deleted or renamed, the folder is renamed, whether the application will consider that or auto sense that or not. Then bug fixing also, there one bug fix. So number of paragraphs are different for Windows and Linux. So that need to be cross checked how to resolve this issue. Then the demo is, now we saw the demo. Demo is 100% completed. So let us conclude